Fall Protection for Construction, Module 1, Introduction. Thank you for taking the time to learn more about workplace safety. We're glad you're here. First things first, if you haven't taken the Fundamentals of Fall Protection course, we strongly recommend that you take it before proceeding through this course. With that being said, over the next few minutes, I'd like to fill you in on what's coming up in this online course on fall protection in construction. This course is designed to ensure you have a solid foundation to build or manage your own fall protection program, or begin using fall protection at the job site. It is not designed to be a replacement for your company's fall protection training, as it does not meet all requirements. However, we recommend that you use this course as a supplement to enhance certain aspects of your training program. For your convenience, each video in this course is available on our website and our YouTube channel. We interviewed knowledgeable users of fall protection to provide an opportunity to present this information to you. We begin by discussing common hazards and how to plan for fall protection. We cover the basics of selecting the right equipment for the job, proper usage, inspection, maintenance, and training. To ensure this course is practical for you, we talk about situations that are specific to construction activities. Once you've completed this course, there are 4 other courses in the Fall Protection Suite to choose from. These are Fundamentals of Fall Protection, Fall Protection for Roofers, Walking Working Surfaces, and Ladder Safety, which we highly recommend in conjunction with this course. If you have any questions along the way, feel free to give us a call at 503-947-7443 or email ed.web@oregon.gov. Let's get started.
When you think about the hazards that you see on any construction site, be it new construction, remodeling, probably the biggest catastrophic hazard there is falls from height. And we see that year after year. I don't think a lot of contractors or a lot of business owners take a look at what's going to happen if somebody does fall, that human cost.
Gravity is the one thing on the planet that does not discriminate. Other than the fact that it's the law, it's just best practice. We want to be able to work and do the jobs that we do, and many of them are hazardous. Fall protection is just one element, but a very specific element that, again, will not change regardless of race, creed, color, religion. It is just a reality. And the best thing to do is to be able to work safely so that you're protected and that you go home.
Obviously, I think safety is important to everyone, and as a contractor, you want to make sure everybody's protected. By the end of the day, you want to go home and feel good that it was a good day, it was a productive day, and nobody got hurt, and you treat employees as part of your family.
A lot of the people I work with are very small outfits, one crew, 4 to 5 individuals. You become like a family, right? You know what each other's kids are doing, you know what sport they're in, you know what their spouse is doing. I don't think they think about the fact that if they allow somebody to get up there and work without fall protection and they fall, that's one of your family members that just got hurt. And I don't think they think about it in that fashion until afterwards when it's too late.
Fatal work injuries. In 2017, 971 construction workers died on the job. Of the 971 fatal work injuries, 386 were due to slips, trips, and falls. Source: Bureau of Labor Statistics. Accepted claims. In 2017, there were 5,780 resolved claims in Oregon that were due to slips, trips, and falls. The average cost for these claims was $23,570. Source: Oregon Department of Consumer and Business Services. Accepted claims. In Oregon, between the years of 2014 through 2018, there were 6,187 accepted disabling claims in construction that were due to falls to a lower level. Number 1, ladders, 1,980. Number 2, vehicles and machinery, 1,530. Number 3, stairs, 853. Number 4, roofs, 282. Number 5, scaffolds, 212. Number 6, floors and walkways, 80. And other, 1,250. Source, Oregon Department of Consumer and Business Services.
When we're planning on fall protection for the project, there's two main things that go into that. One is knowing what work's going to happen and how that work happens. You have to be able to understand what the worker does, no matter if they are doing a hot applied roofing situation or if they're doing a large structural steel erection. And so you have to know how the worker does that work. All right. The other thing that you need to know is you need to know what's out there and available to help protect that worker. If you only know one of those, you can't understand how to do the work and how to implement it and how to advise that team on what they need to do and what's going to help them the best. I usually identify high-risk activities, and then at that time I work through the plan with the team that's going to be doing it, or at least the foreman and superintendent that's going to be performing that work. And I like to have them tell me the plan, and then I also know how that work's going to go, and then we identify certain areas where we can eliminate risk, and then we try to have a plan before we even get started to eliminate that. Again, when you have a plan that you can work around and it lets the worker do their work without trying to figure out how to get around handrails and tie-off systems, something that's easy for the worker to use, that's going to be the safest way to do it. We also go and daily job walks. I try to sit back and watch the workers. Not that I'm waiting for them to make a mistake. I just want to see how they're working, how the flow is, where the walkways are, where we're on leading edge work and when we're not on leading edge work, where we have risk of dropping something, where we don't. A lot of it's just keeping your pulse on the work that's going on. You know, and you can't do that in the office. You have to be out there in the field. And then the other part is research, education, talking to the reps from the companies like DBI Sala and Guardian that are in Portland, and people like Hilti, Engineered Systems, things like that, and seeing what's out there and constantly, because there's new things happening every day that people are inventing. Also at Hoffman, we try to have meetings where we exchange information, what's working with us, what are the results of it, and then also we try to drill down into systems that we're already using on how to make those better. And so it's really a team that takes to do that.
My name is Dan Daly. I'm a framer, and I work for Daly Construction Company. I've owned the company about 30 years, coming up, 29th year. So as a teenager, oftentimes it was actually assigned to the youngest person who had the least amount of wherewithal to refuse a dangerous order. And as a kid, I did some really dangerous, stupid stuff, but I survived. And then as I became older, when I was in my early 20s, I started actually defying foremen and telling them, not very politely to go. And I'm like, yeah, you walk that wall, you get up there and, it's like right after you, buddy. And most of the time, those guys were not interested in doing the dangerous thing. They were interested in having someone else do it. And so as I progressed and opened up a company, I didn't want people to do things that weren't safe. And I certainly didn't believe in the safety gear when I first opened my business, because it didn't even exist. But over time, I had a competitor that called OSHA on me for, I think, every job for like 3 years. And I was faced with going out of business or converting. And I converted to actually believing in safety gear. I was falling one time, and the safety gear went from being a nuisance that I did grudgingly to avoid OSHA fines to actually something that kept me from going off the roof. And in that come to Jesus moment, when I'm looking down and I see all the rebar sticking up from the masonry and there's no caps on it, I realize that, hey, the safety gear is actually not a bad thing. Nobody should get hurt to make a buck. It's not a prerequisite. There was a time before all the safety stuff was invented where it was a cost of doing business. But that's not the case anymore. We framed over 1 million square feet. I've had employees work for me, some of them 20 years, and I've never had a serious disabling injury with workman's comp. It's evident with what we do that we try. We're not perfect, but we're pretty good. And at the end of the day, just the record speaks for itself. I have low employee turnover because I don't hurt people. None of my guys fall off the roof. None of my guys, it just doesn't happen. And my employees are my friends. I don't want anyone hurt. That's the bottom line.
Ladder safety. Ladders are the leading cause of death and injuries in workplace slips, trips, and falls. As we close out this module, let's take a few moments to review key points for using ladders safely at your workplace. Ladder inspection form. A ladder inspection form is a valuable tool for identifying some of the hazards that are present when using a ladder. The benefit is that you can see if there are trends developing, like defective parts. If any defect or damage is found during the inspection, you must do the following. Number 1, tag the ladder. Dangerous, do not use. Number 2, repair the ladder immediately to its original condition, or destroy the ladder. NIOSH Ladder App. Scan the QR code to download the NIOSH Ladder app. This app can help with planning, selection, inspection, setup, proper use, and accessories. The app is only available to mobile devices like cell phones and tablets. Access to upper landing. When portable ladders are used to access an upper landing, they need to have the side rails extend at least 3 feet above the upper landing and must be secured to the structure. Do not place any weight on the rungs located above the upper landing when using non-self-supporting ladders to access an upper level. 4-to-1 ratio. Extension ladders need to be placed so that the working length of the ladder is 4 times the horizontal distance from the ladder's base to the structure. This is a 4-to-1 ratio. Ladder safety training. If you would like to learn more about ladders and how to use them safely, check out our online ladder safety training. Fall protection for construction. Module 2. Options.
So a guardrail system is something to keep people from basically falling off of an edge or out of an opening. And the idea behind it is that you have a top rail that's set at 42 inches plus or minus 3. You're gonna have a mid rail that splits the distance between it and the ground. And then if you have somebody working under you, you're gonna put up a kick plate. And this is gonna stop things from getting kicked out over on top of employees below you. Typically these are all made out of 2x4s in most cases. The place that I've seen most innovation when it comes to guardrail systems is framers that are putting these guardrails on the walls before they're stood. So by the time the wall's vertical, it already has a guardrail for the next level. Something else that I've seen with the guardrail systems is they have these prefab sockets that you can basically bolt to the side of the structure. It's a little bit faster, it uses less material, and I've seen some larger outfits use this, especially on large commercial projects.
How effective are guardrails? When I run projects and set up activities to happen on a construction site, will always try to be in fall protection. Top rail, mid rail, toe board, and naturally you on the common sense side of that assembly, because essentially eliminates fall arrest.
Usually we use them around holes in the floor system. Like if the perimeter, like when we're building a second floor system on a building, we'll be tied off wearing our fall protection till we have the perimeter wall stood. And then once that's, stood, all you got to do is put your rails through the window holes, and then you can't fall. But there's usually going to be like a way to get up from the first floor, and that's going to be a stairwell or an elevator hole or what have you. And those we build guardrails around.
As far as building guardrails and safety rails, it just depends on what the construction material is that you're having to work with. But building a wood rail, again, the bottom rail 21 inches up, the top rail at 42 inches, it's not terribly difficult. It does need to withstand the weight of someone leaning on that rail. So it does need to be positively fastened. It needs to withstand, side pressure of 200 pounds, so it does actually need to be built correctly, but very simple to do. And there's also products available on the open market that you can buy that are an easy bolt together system that will do the same thing.
Guardrails. The benefit of guardrails is that after they are installed correctly, they reduce the amount of human error. Parts include top rail, mid rail, and intermediate vertical members. They can be combined with toe boards that prevent materials from being kicked or rolled off the walking working surface.
A positioning device system is something that you use when you're working on like a vertical system. For me, where I typically saw this used was ironworkers, people that were tying rebar on retaining walls or columns. And the idea behind it is that they're typically two hook systems. And this is so that the ironworker can climb up the wall, the structure, and basically hook off and then lean back into it. So it's always got weight on it when they're working. And it's to keep them from falling, but it's also to give them an ability to use both hands while they're working.
Positioning device is something that typically connects to the side D-rings of a fall protection harness and allows a worker to use that as their third point of contact. Because when we are climbing, when we are working at heights, we have to maintain 3 points of contact on a ladder, a rebar cage, form walls, something like that. Either 2 hands and a foot, 2 feet and a hand. When I need to work on a ladder, rebar cage, column, any place where I'm climbing, and I need to take both my hands off to get the job done, I no longer have 3 points of contact. So a positioning device is something I can connect that allows me to connect to my structure and maintain that third point of contact. I can lean back into that positioning device, work hands-free, and still maintain 3 points of contact. With a work positioning device, I also have to make sure that it is short enough that I'm limiting my free fall to 2 feet or less and still have a 3,000-pound or 2-to-1 safety factor on my anchor points. You'll see positioning done quite a bit in construction with our form workers, concrete workers, iron workers in construction, people who are climbing towers, either in the wind or telecommunication industry, climbing towers, they use a lot of positioning devices. Also in the electrical utility industry, we use a lot of positioning. A lot of times when linemen are climbing and they finally reach their destination, they can use one of their positioning lanyards to go around the pole as long as it is connected in such a way that it limits them to a maximum of 2 feet of free fall.
Positioning device system. Positioning device systems support a person who needs to work with both hands free on surfaces. They are commonly used on formwork and for tying rebar. They provide support and must stop a free fall within 2 feet. Parts include anchorage, connectors, and body support. Positioning devices must be secured to an anchorage capable of supporting at least twice the potential impact load of an employee's fall, or 3,000 pounds, whichever is greater.
We see fall arrest and fall restraint talked about quite a bit, and it seems like there is some misunderstanding sometime between the two. When I'm working in fall restraint, what I like to describe that as I'm like a dog on a leash. I have a fixed length connector going back to an anchor point that is set in such a way that when I'm using it and I have that extended out to its maximum length of travel, I can't get to that hazard. If I'm working next to an edge, I can't get my feet, I can't get my butt over that edge. There's no way I can fall. My system is actually set up to catch me and protect me before I have a chance to fall. My anchor points don't have to be as strong. My system is a lot easier to set up, it's a lot easier to train for, and rescue is really, really simple. If somebody falls when they're in fall restraint, they can simply stand back up because they should be on the same level that they were walking on already. It's a very, very simple system. When we move to fall arrest, The systems and the components that you're connected to are doing absolutely nothing for you until after you go off that edge, until after you fall. And once you fall, they should be designed so that they stop you before you can hit a lower level or the ground, and then arrest that fall and bring those forces down to an acceptable level, which is 1,800 pounds by OSHA, or an average of either 900 or 1,350 pounds by ANSI, depending on what product it is. Fall restraint in Oregon, we need 3,000 pound anchors. In fall arrest, we need 5,000 pound anchors or a 2-to-1 safety factor. So I have the correct anchors. What happens after the fall? Do I have systems set up so that I can rescue the person who's just fallen? Does everybody understand that there might be some swing fall involved and that they're further down than they thought they might be because they were off to the side and they were able to have a swing fall? So there's a lot more that has to be done. There's a lot higher level of training that has to go on with fall arrest than there is with fall restraint.
When you think about it, would you rather get stopped before you fall over the side, or would you rather get stopped and have that harness tighten up on you in a very uncomfortable way? So when it's feasible and when you can do that, I think that the idea is, to me, this is part of that hierarchy of controls, right? If we can stop somebody from actually falling over the edge and not have to recover them, I think that's going to be beneficial. It's going to be faster, it's going to be safer for your employees, and probably a lot easier for them to work. So I definitely think there's benefits to using that over fall arrest.
Fall restraint systems. Fall restraint systems prevent workers from reaching an unprotected edge, thus preventing a fall from occurring. Parts include lanyard, connectors, and body harness or body belt. The anchorage must support at least 3,000 pounds or be designed and installed by a qualified person and have a safety factor of at least 2. This means the system is capable of supporting at least twice the potential impact load of an employee's fall. Fall arrest systems. A personal fall arrest system consists of an anchorage, connectors, and a full body harness that work together to stop a fall after it has already occurred, and to minimize the arresting forces of the fall. Other parts include lanyard, deceleration device, and lifelines.
Tragic accident today for a construction crew while on the job at a Miami site on Miami Beach. A worker taking a nasty fall and essentially dying from his injuries.
This man was impaled on rebar. He was up on the 3rd floor there, working on the 3rd floor. He fell to the 2nd, 12 feet or so, but he landed on those metal rods that are there to shore up concrete.
And I'll get your attention right here. People don't do it. They're going to do a curtain wall, right? They got 4-foot rebar stubbed out. They didn't add it in. You can go on the internet and look at it. It goes in right about the thigh and comes out right about the armpit. You know how they get you to the hospital? They cut the rebar.
When we talk about fall clearance and how to calculate our fall clearance, being able to calculate that clearance properly is really, really important. Let's start with our lanyards. When we calculate fall clearance for our lanyards, we're always calculating from our anchor point. We're not calculating that from our walking surface. So the first thing we have to do when we calculate our fall clearance is we have to know what is the first thing that we could come in contact with. Is that a lower level? Is it the ground? Is it something that may be stacked on the ground that could be the first thing that we come in contact with? We also have to know what the length of the lanyard is that we're using and what the deceleration distance is on that. When we calculate fall clearance using a lanyard, we start at our anchor point. We start with what our maximum free fall would be, which is 6 feet, the length of the lanyard. We go into the deceleration distance on that device, which would be 42 inches, 3.5 feet by OSHA standards. Then we have the distance from the worker's back D-ring to their feet, which on average is probably about 5 feet. Our body's going to conform into the harness. That back D-ring is going to stretch up about 1 foot, and then about 2 feet of safety clearance, just in case things weren't quite where they needed to be, or we have workers of different weight, brings us to a total of 17.5 feet. So using a standard 6-foot lanyard, we could need a total of 17.5 feet from our anchor point to that next level. That's 6 feet of lanyard, 3.5 feet of deceleration, 6 feet of worker and harness stretch, and our safety clearance at the end for a total of 17.5 feet.
What happens when you fall? The first thing that happens is you're going to engage. Okay, you're gonna fall. It depends on how long your lanyard or whatever is. Your free fall distance is gonna be anywhere. If you're on a 6-foot lanyard, it's 6 foot. But people don't think about it because what happens is everything else comes into effect. We have the shock pack comes into effect, the height of the person. If you think about it, you know, stretch of the harness, the safety factor. So, I mean, it can be anywhere from about 12 feet. If you're on a retractable, we could get you down to about 12 feet. But if you're on a 6-foot lanyard, it's gonna be close to 18 feet. They don't do the calculations and they don't add that 18 in, or they add it wrong and they hit something. My buddy over here just parked the forklift underneath me. Okay, I didn't add that in. They're gonna do a curtain wall, right? They got 4-foot rebar stubbed out. They didn't add it in. You can go on the internet and look at it. It goes in right about the thigh and comes out right about the armpit. You know how they get you to the hospital? They cut the rebar. Or, how about this? You're on a tilt wall and you do that same thing, right? You know what you do? You touch that wall and what do you think the first thing is? You start spinning because you're out of control. You have this much control. The only problem is on a fresh tilt wall, you got form spikes, rebar, 2x4s. Yeah. How about windows? Go through a window at 40. They'll bury both halves of you, I promise. But they don't keep that in mind. Or there's a rebar-filled concrete column at B. You just hit it at 40. Think that column will be there in the morning? Oh yeah. Think you will be? Oh no. And it'll have a decorative red spot on the side of it. Because you can't take the forces. It will kill you faster than you knew. You just can't take the forces. So that's the problem, is they don't do the calculations. They don't do the math. And I always say fall protection's 2 things: a set of numbers and a set of mistakes. And if we can take the mistakes out of the equation, every mistake we take out, we're better off.
Swing fall. Swing fall is created by the pendulum effect, which can swing a fallen worker into a nearby surface, such as a wall or protruding beam. It is important to evaluate the swing fall hazard at any edges where a worker might fall. A worker who falls while connected to an anchor, unless it is directly overhead, will swing back and forth like a pendulum. Workers can be seriously injured if they strike objects during the fall. Installing the anchorage point directly above the work area, examples include connecting to an overhead attachment point with sufficient strength, will prevent swing fall injuries. Fall Distance Educator. Scan the QR code to view Oregon OSHA's Fall Distance Educator. The educator will provide you with 3 different scenarios.
When I try to educate people on how to use harnesses, or in my orientation, I talk about, I try to touch on things that other superintendents don't touch on during the orientation, because a lot of these people who come to the Hoffman job sites have been to a dozen others in their career. And so I try to hold their attention by talking about something maybe they haven't heard about. And one of the things I do talk about is the straps that are on the side of a lot of harnesses over your hip area. If you do fall, you sit in that harness until somebody retrieves you. If you're in an area or somebody doesn't have a plan, doesn't know how to retrieve you, you could be sitting there for a while. It's going to take the fire department, if you're 200 feet off the ground, they have to be called, they have to arrive. You're going to wait there until they figure out how to reach you. You have minutes sitting in a harness while you're dangling there and all the pressures on the inside of your thighs on that femoral artery until you start to develop a clot. And so developing a clot there is going to depend on if you have a blood disease, how healthy you are, how much trauma you had when you fell. And so those straps right there are extremely important. I tell everybody that if you're going to be wearing a harness, you want those straps there. Because if you aren't deploying those straps and you understand how to deploy it, hook it together and stand in there, you're going to sit there and you're going to get a clot. Now, the clot isn't the problem. The problem is when you get taken out of that harness and that clot gets let go out of that femoral artery and where it travels to. Because if it travels to your lungs, it can cause a pulmonary embolism, or if it goes to your brain, it can cause a stroke, okay? And so it's extremely important. If people think just putting on a harness and tying off correctly is all they need to know, they're only halfway there. And falling in a harness is bad. Falling in a harness and having a stroke and having paralysis on the side of your body and losing your speech and changing your whole life, that's a big deal.
An SRL is a self-retracting lifeline. Some of the common names that we'll hear is a block, a solid block, a yo-yo, are some of the slang terms that are used for a self-retracting lifeline or SRL. ANSI, with their Z359.14 standard, has broken SRLs into a few different categories, from SRL-LE, which are the leading edge devices, which may be leading edge, and they may be leading edge, sharp edge devices. SRL-R devices, which are devices that can provide rescue built right into the systems. We have SRDs, self-retracting devices, which are more of the personal size devices that are meant to replace the traditional lanyard. There are a lot of different styles out there. We have styles that are cable, we have styles that are web, we have styles that have been developed for hot work, for use when people are welding or grinding around higher temperature work activities. We have devices that have been developed for arc flash, for when people are working in high voltage applications, or electrical workers that are working at heights around high voltage panels that can withstand those up to 40 calorie arc flash blasts. So there's gone are the days where an SRL block yo-yo was a piece of cable or a web and it was one size fits most, to devices that are highly specialized and made for very specific work activities, tasks, or protecting workers in very specific dangers.
And in the beginning, I was counting pennies, and I bought, the first thing I bought were the ropes and the roof mounts, because they're the cheapest. And you can get like a fairly inexpensive harness in a bucket for like $100. Any lumberyard's gonna sell them. I was doing some apartments for R&H, or there were townhomes called Pence Place, and I'm on the roof, and I got a gun in one hand and I got a saw in the other, and I'm all tied off, and I step on my safety rope, and it rolled under the heel of my foot, and I landed on my tailbone. I don't know if you've ever done that, but it's excruciatingly painful. Well, that taught me that it's well worth the extra $1,000 to buy a retractable, because the retractable, as you're walking, it always sucks the slack up. There's always tension, and you can't trip on your safety gear. Whereas the cheaper ropes, you manually must always adjust the length, and that's in theory, but in reality, most guys don't, and they drag around a surplus of rope, and invariably, like I discovered that day, you end up not seeing the rope when it's behind you on a roof and it's uphill, and then when you step on it, it rolls by virtue of just physics, and then you fall. My philosophy now is retractables when possible. I have some really old guys. I got probably 5 guys that are late 50s to early 60s. The retractables are hard on their backs, so usually I don't put them on the roof, but if I do, and usually it'd be like a flat roof, they're gonna wear a rope because it doesn't pull on their back. So I still own probably 4 ropes, but we almost never use them.
Self-retracting lifelines, SRLs. Self-retracting lifelines and personal self-retracting devices, SRLPs, have been around for more than a decade, and they offer many advantages over shock-absorbing lanyards. These devices are less likely to interfere with work tasks, and depending on how they are used, can severely limit the distance a worker can free fall before they are arrested. These devices should be mounted directly overhead to an anchorage that can support 5,000 pounds and with no slack in the lifeline to minimize the potential for a swing fall. Always check the manufacturer's instructions, read the manual, and follow their safety warnings before using these devices. Fall protection for construction. Module 3, Anchors.
So an anchor is the portion of a fall protection system that you actually use to attach to the structure or whatever it's you're going to use to support your weight in case you fall. Typically the type that we had typically used were the flat style anchors that you could nail down to the top of a roof. And it basically has a nail plate, certain number of holes, you have to fill all of them up for depending on what type of system you're using. We've also seen anchor systems where they bridge several trusses. Things like that can be positioned around, moved a lot easier. Another type of anchor that I kind of wanted to talk about was the permanent anchors. And you can find these anchors for about $20 to $25, and the idea is they go underneath the ridge cap on a roof. So as your roofers are going up, they put this anchor in place and then cover it over with the roof cap, and that anchor stays there for the life of the roof. So that if anybody, including the homeowner, has to get up on the roof, they already have something set in place to tie off to.
The anchors that we use the most are depending on the job we're at. And so I just finished a indoor gas station with 70 pump heads and 16 car washes. That was only 2 stories tall. And so there we used a mobile set of tie-off anchors, which actually rolled around and had a weighted system in there. And so it worked off friction. And so we could take it to the edge and then people would be tied off that way.
The most popular type of anchor is either going to be a mechanical one, like a wedge anchor, where you drill a hole and then there's a mechanical way for that to tighten up. It has engineering behind it. My favorite is cast-in anchors. Not only do you have the anchor and the pull-out of the threads of the bolt that you're using, but you have, all the concrete there as well.
At this building, we use anchorage to attach our linear ropes for our harnesses, and it's set up on a roof. Each ridge of the roof has anchorage in there. And on this particular building, it was already pre-installed, but we verified it was installed correctly, because you don't want it to have somebody mistaken install just over plywood and it will just rip right off. You want to make sure there's a solid framing on both sides, has the proper fasteners. So you don't want to just to kind of install it. So, and that's what they tell all the guys too. If you guys have a rope hanging from the roof, you gotta go make sure that's installed. You don't want to just, what if somebody just left it, proper procedure, make sure it's hooked up properly, tested it, talk to your supervisor, supervisor has to verify it so everybody knows, okay, green light, you can go ahead and use it. So yes, if it's not set up, everything is worthless. So yes, it starts from the top, make sure it's properly attached, make sure a rope is properly attached, and obviously, hey, it could have been an old building or it could have been rusted out, so maybe there was a time to replace it. So want to make sure that it has good condition, and you want to verify, we actually talked to who installed it as well. So make sure it was done correctly, and they also talked to the management company verifying that everything was done properly, and so we can go ahead and safely use it.
Common anchorage points in residential construction. A lot of times we'll see people tying off to the peak as far as putting an anchor nailed to the sheeting on the peak of the roof. We've also seen the straps nailed to the floor, typically used with the self-retracting lifeline styles. There's ones that span across several trusses for anchors. One common one we'll see that obviously isn't approved is people will wrap their rope around the peak of the truss, around the rafters, and it's like, I get that may handle that weight, but it's not rated for that, and you don't truly know if it will. So, and actually, there's a leave-in anchor as well that can be used for the attic that you basically nail to the side of the peak of the trusses, and this provides an anchor point for if you're going to be working in the attic or, say, above a stairwell.
Anytime we need to tie off, there needs to be a positive anchorage point. The most common for us is either a screw down or a nail down plate with the steel loop on that. There are situations where if we get the engineer's approval, we can tie off to a piece of steel or even a truss if needed, but that does need to be approved by the engineer to carry the load.
Well, you always want to make sure that you're fastening through the decking into the members below, the framing members. So the nails are going to clearly indicate, and you're going to feel as you're fastening your anchor points, you're going to feel as you're fastening, if you're going through plywood only, that's called a shiner, and it's not doing anything. But if you hit resistance as you're driving the nail in, or we use screws, then you know your roof mount is attached properly. And I call it a roof mount, but in this context, it would be a floor mount. But it's an elevated, it's like a gun turret, and it just rotates 360 degrees so that the retractable yo-yo, or whatever you want to call it, is facing you. And every time you walk, you know, it's paying out your fall protection. And as you walk back, it'll suck it back in. Hedge your bet towards safety. There's always a way to be safe, and you can tie off above yourself, and you can roll joist. And the moment you've got a couple of joists rolled or a beam rolled, then you have something you can mount, one of those roof mounts, and then you're able to work a certain radius, and then again you do another one, so that as you keep going, you put another retractable, or you put something so that the person can keep working and not exceed horizontally the vertical drop. Because at that point, you're wasting your time. You might look good to a compliance officer driving by, but that defeats the purpose, because in the end, you're only cheating yourself, you know, or your crew members, by allowing them to not be safe.
There are many of us that work inside or in other environments where we don't have a walking surface such as a roof or a substrate such as that. Take an iron worker or something similar to that, where we have an exposed I-beam. Another common tool is a beam clamp or a beamer clamp that is designed to attach around multiple flanges merely by just squeezing that trigger and getting it around one side of the I-beam flange, bringing it up like that, and then you will just slide it in, connect, and then we would hang our retractable or put our lanyard to that, and then it would be suspended from the I-beam. Another very common, especially when we talk about exposed I-beams, angle iron, or even exposed columns, concrete columns, partially or fully poured, is what's called an anchor strap. This is extremely useful, and they come in various lengths. Standard usually in the market is 3, 4, 6, 8, 10, 12, and 20 feet, but many manufacturers can even make them of custom lengths, depending on what we need to wrap this around. The nice thing of these is that they're very easy to install. The structural part is this black part, where you can see that's where the webbing is sewn in and the D-rings are. And the yellow backer part is that of a softener. So as you're wrapping it around something that has sharp or burred edges in the construction world, and you just choke it back around whatever anchor it's like that, and then you can hang your retractable from there. If you're using a horizontal lifeline, in many cases they can be used vertically this way, putting some tension in. The other benefit is that although it is as strong as it needs to be in this configuration, they are designed so that if necessary, you can do multiple wraps. Just make sure that it always pays through all of the way. That way you can get the connection as close to the anchor or the structure as possible. Just make sure you get a full choke through. Make it line up, and then we got it tension, and it will hold its position, and then we have a correct or a compatible connection for our anchor or lanyard to be connected. Any anchorage attachment, beam strap, or other device, it is still imperative that when we're on site, other than following the manufacturer's instructions, that we still have to verify that the structure that we affix this to isn't just something random, that it is still evaluated either by a competent person or by a qualified person. Laying one truss doesn't make it structurally sound, and at some points, no doubt, you will have to have somebody actually do engineering or prove that it is capable of withstanding the forces. We talked about working on top of a top plate, and that the framing is up, but is it really an anchor? Can it sustain the loads applied in a dynamic fall from it pulling over? If the trusses, you only have 2, and if we're all to the left side, will it pull everything over and just collapse like a house of cards? If I'm attached with an anchor such as this, and it's only attached to 26 gauge, and the manufacturer requires 12 gauge, depending on what it might be, then we know that it's not attached to something that will withstand the forces that it's designed to apply to the structure. So always be sure, not only do we select the right tool for the job, that we install and assure our workers install it the appropriate way in the appropriate place.
Anchor types. Engineering clamps are often associated with 4 different anchor types. I-beam clamp, which adjusts to numerous steel beam sizes. Trolley beam anchor, which allows workers greater access to greater work areas without the need for longer lanyard. Standing seam metal roof anchor, which clamps to parallel seams of metal roofs. Doorway and window opening clamp, which allows for anchoring between building framing or window openings. Anchor types. Strap anchors are often associated with 3 different types of anchors. The cable anchorage sling, used around structural steam or I-beams. Drop-through anchorage cable, suitable for concrete or steel, has an anchor point that drops through a small hole in an overhead surface. Or strap anchor, which is used for sturdy, horizontal surfaces like beams. Keep in mind, sharp or rough edges could lead to strap damage. Anchor types. Concrete anchors are often associated with 3 different anchor types. Concrete anchor strap with D-ring, typically used for foundation and formwork employees. This strap is protected from abrasion by the concrete with a sleeve or wear pad. It is looped around the rebar during pouring and is cut flush with surface when it's no longer needed. Precast hollow core concrete anchor, which allows one worker to tie off, is often used for precast hollow concrete tasks. Bolt-on wall anchor, which can be a temporary or permanent anchor point on a vertical concrete wall. Anchor types. Anchors not welded or clamped in place are comprised of mobile fall protection systems that can be quickly moved from location to location, come in versions that allow for more than one employee to anchor. Rotating retractable anchor mast, which is most often seen on sloped residential roofs. It allows a worker a large range of motion and helps to elevate the anchor point above the worker. Deadweight anchor, which is commonly used when performing roof work and you cannot hammer or drill into the surface. It is made of concrete, steel, or similar heavy material to provide anchorage. Bolt hole anchor, which is used in horizontal steel bolt holes. Anchor types. Additional anchors include welded D-ring anchor, which is a single D-ring anchor point that can be temporary or permanently welded onto vertical structural steel. Weld-on anchor post, which is a permanent anchor point that is welded to an I-beam. Trench box guardrail anchor is used for performing deep excavation. It is designed with an anchor point on a post near the guardrail. Fall protection for construction. Module 4. Scaffolding.
Scaffolds are a very common way and a fantastic way to get multiple workers up at an elevated surface. I would say throughout my career there's probably not one job that I have not used scaffold on throughout the course of the project. It comes in a variety of applications. I would say a baker scaffold or conventional scaffolding is the most common way, but there's swing stages, mechanized scaffolding, there's Bozeman chairs, there's many applications for scaffolding. You can use scaffolding as a catch platform. I don't do that as often. We will default towards a guardrail system if we can. One of the most important things, paramount in scaffold operations, is proper employee training. And I mean proper employee training beyond just a red tag or a green tag hanging at the bottom of the scaffold. Some of the biggest incidents in our industry are scaffold failure. And when something goes wrong with scaffolding, it usually goes wrong pretty big. And whatever's up on the scaffolding is coming down, and whatever's under the scaffold, is at risk of getting hit by that. And it is hugely important for the workers that are getting on the scaffolding to know what the manufacturer's instructions are, and that they are trained to recognize if that scaffold is safe for them to work off of or not. Some common mishaps on scaffolding, planking. You need to make sure that you're not using dimensional lumber for the planking, that you're using actual OSHA approved planking, that your planking has a proper overlap from plank to plank and from scaffold bay to scaffold bay. Fully cross-braced systems, that on conventional scaffolding that all your cross braces are in everywhere on the system. that if you exceed the 4-to-1 scaffold height, that your scaffolding is tied back into whatever structure you're working off of. On swing stages, there's a whole different set of rules that go with them. I would say on swing stages, you want to make sure that you have primary and secondary fall arrest, and that your fall arrest system for your workers on your swing stage is completely independent of the swing stage itself.
Scaffold A to Z Topic Index. You can use a scaffold to work on just about anything. Silos, tanks, chimneys, bridges, stairs, roofs, ramps, and ceilings are just a few examples. In its most basic form, a supported scaffold is just a platform and a set of uprights, so many people think that anyone can set it up. This is why so many workers are injured or killed when they use a scaffold. Components fail, planks break, handrails give way, or the entire structure collapses in a heap. Most scaffold accidents happen because scaffold users are untrained or improperly trained. We highly recommend you take a moment to explore the resources in our Scaffolding Topic Index page. Scaffold types. There are two basic types of scaffolds. Number 1, supported scaffolds. These are one or more platforms supported by outrigger beams, brackets, poles, legs, uprights, posts, frames, or similar rigid support. Number 2, suspension scaffolds. These are one or more platforms suspended by ropes or other non-rigid means by an overhead structure. Competent persons in scaffolding. A competent person for scaffolding is someone who can identify existing and predictable scaffold hazards in the workplace and has the authority to take prompt corrective measures to eliminate them. Scaffolds and scaffold components must be inspected for visible defects by a competent person before each work shift and after any event that could affect a scaffold's structural integrity. Scaffold training. Employees who erect, disassemble, move, operate, repair, maintain, or inspect scaffolds must be trained by a competent person to recognize hazards associated with the task. At a minimum, this training must include: Number 1, the nature of scaffold hazards. Number 2, the correct procedures for erecting, disassembling, moving, operating, repairing, inspecting, and maintaining the type of scaffold in question. Number 3, the design criteria, maximum intended load carrying capacity and intended use of the scaffold.
Scaffolding is, you think about safe way to climb up or have accessibility on the challenging areas around building or structure. So if scaffolding built proper way, it can work very, very safely in there. It's basically a platform, if it built correctly, installed correctly by a professional staff that has a good safety procedures of building and implementing it and inspecting it, you'll provide a very excellent working conditions. And I think we found it's probably the most efficient way without constantly removing or adding, where you can actually set it up and continue to do the work until the work is done. You can safely take it apart. So that's, in our way, is really scaffolding will be like a safe way to do the job. Because there's other methods as well, but I think this takes more time initially, but actually will save a lot of times in the long run, because you don't have to constantly, like palm jacks, move it up and down, or ladders move it up and, all this, and that's kind of a little shaky, so I don't think the guys that feel as comfortable. Here is really, you feel stable. The guys also build themselves, they inspect themselves as well. We obviously inspect it as well. So this way, everybody knows it's safe and keep it out on a daily basis that it's safe to use. And it really truly helps us to do our job right. So we want to have and make sure that we have a sufficient space, safe space, to be productive and do the right job. So we decided the best option is just to purchase scaffolding and assemble it and make sure it's done correctly. And we're not pressured by anybody to, there's another monthly payment coming up, or you got to do this, you got to wrap it up, We want to make sure it's done right on our terms. So this way we don't rush with safety, we don't rush with the procedure, and when it's ready, then we can move it ourselves. Well, obviously it starts from ground up, so I want to make sure that surface is properly prepared. There's some uneven surfaces, so I want to level it out, or want to do some digging to stabilize it. We want to have a solid base because we don't want something, be depressed in the ground later on, because obviously rainy season is coming. So what we have now might be different later on. So I want to have pretty wide base underneath the scaffolding. And Then, once we start building up, we want to make sure it's level. We choose the position where it's best, closest to the building, and we can work properly and set up properly. And start basically assembling. Obviously, it requires about 2-3 people, so one person holds it, another one adjusts it, so we kind of make sure the right guys have a proper training for that. And basically go from all the way up. Once we get a couple frames, couple levels, we want to make sure that it's properly attached to the building and keep going higher. We always tell the guys, hey, every time you climb on the scaffolding, really take a look how things are set up, you know. So obviously we do pretty often an inspection of it, but as a general rule, anytime you climb, especially on a ladder, you want to make sure the bolts properly secured, the nuts all the way tightened up, so you don't want anything loose on the scaffolding. You know, if you notice anything out of place, do not use it immediately. Bring it to attention your supervisor and start correcting the issue. So I want to make sure that scaffolding. Sometimes, you know, you have to rechange some of the connections to the wall, and due to the work performance, so you want to attach the other point. How do you anchor and secure the scaffolding to the building? And so not any point you want to make it a little less structurally, well, safe to use. So for each crew has a supervisor. You want to make sure that everybody's engaged in a safety process. You know, things can fall off the scaffolding very, very easily. So maybe somebody passing by, so you want to make sure there is some guards against that. You want to also make sure that you maintain your scaffolding, you clean it up. You know, you don't put things close to the edge. You don't put things that necessarily have to be there. So there's other areas for that. So whatever you bring the stuff, you want to make sure that it's not gonna disturb the balance of it. So you want to make sure that it's kind of, you know, common sense, obviously, and good training. Constantly be aware of it is a proper way. So our supervisors will kind of inspect it with the guys, and we'll have different crews go to each other scaffolding as well to kind of look for different things, make sure everything's properly, and kind of point it out. Because as you become in your daily routine, sometimes you don't notice, like, hey, there's too many screws here, and there's some lumber here that really, you know, you can easily just knock it down and fly over. So safety for the guys that walking around, they has to be aware. We don't want it, but what if something falls, you know? So you want to be constantly aware if there's a danger, and this platform is there to, you know, help us do the job. We don't want anybody to get injured to that. So I want to be kind of aware of it and kind of walk away from it. And keep an eye on it, as you want to always be aware who's working the scaffolding, what level, what's going on, what part of the job is doing, are going to have any beams or 2x4s. So you're kind of aware of the process, and you know what to anticipate.
Fall protection for construction, Module 5, Job Tasks.
Framers, they're the ones that come out and they build the structural portions of a house. The floors, floor joists, they frame the walls, install the studs. They'll also install roof systems, rafters, trusses, things like that. Basically, the framer does all the work that needs to be done before somebody's going to put the siding in, or the sheetrock. The plumbers, they're the ones that get the site after the groundwork has been done.
As we're framing, we don't have structure that's able to hold 5,000 pounds or 1,800 pounds. We don't have a lot of fall clearance below the people who are working up their framing. So when we look at that, active fall protection is probably not the most effective means of providing protection for those workers. We should be looking at what can we do on the ground? How much of this can we build on the ground at that lower level and stand up complete? Can we scaffold around it? Can we bring in interior scaffolding in, or work platforms? Can we bring exterior scaffolding or work platforms in? Can we build things off-site, bring them in modules, and set them up so that we don't have people working at heights on thin boards or at very low clearances? Do we have to prepare and do our pre-task planning so that we are setting up large overhead anchor points if we can't scaffold, we can't work off ladders, or we can't have any other means? How are we going to anchor in those situations? Are there things that we can bring in that instead, for interior falls, instead of trying to tie people off and keep them from falling towards the interior, because we use a lot of guardrails once we're framed up on the exterior walls to create protection on an exterior fall, but we still have falls a lot of times to the interior of the building. Are there ways to fill that void with something so that we don't have a 6-foot fall, or if somebody falls, they fall into or onto something like netting for the interior. So we need to start thinking out of the box when it comes to framing and wood framing especially, on what our fall protection solutions could be.
So some of the most common types of fall protection that framers can use to help keep their employees safe, I'm seeing a lot more of guardrails being installed on walls before they're stood, so that as soon as they're stood, as they're framing that next floor in, they already have that guardrail in place. That's a lot quicker than setting up anchors in some cases, and it provides a really good visual barrier as well. I've seen a lot of them using fall restraint, simply because if you're working off of a floor, the idea is that you don't want to have to get to the point where you fall out, right? Another one that I've seen them using is the self-retracting lifelines. It provides a lot of freedom of movement. There's less worry about adjusting for the employee. Wherever they're at, it's adjusted correctly. And I think that's one thing that's really come into play that's helped some contractors buy into the fall protection. One of the other systems, fall protection systems that I've seen mainly framing contractors use is scaffolding, or carpenter scaffolding, where instead of standing on top of the wall plate to say set trusses, they're standing on a built-in scaffolding system. It's a couple of feet down from the top of the wall. And that way they actually have better leverage with those trusses, and they're not exposed to the fall to the outside of the buildings. They're in better control, and they don't have that hazard there. A truss is a prefabbed rafter and ceiling joist system in most cases. And what it does is it's engineered so it can use less wood than you would for a traditional rafter style roof. And it's really useful, especially for really common single pitch or hip style roofs, something that can be prefabbed on, on a fairly production style basis.
The planning process will be another aspect of the fall protection that isn't in the equipment, but in how we plan, how we do the work. Again, changing mindset. One conversation I had with a gentleman they were flying trusses in, and after we discussed, he said, it will be dangerous for me to have a guy, once we have enough trusses set, to have a guy climb up through the lattice work up to the ridge to install an anchor. And I completely agree. You're right, that would be highly dangerous and unacceptable. However, before the trusses were this way, they were laying down this way, or they were on the ground or on the back of the delivery truck. The anchorage and some of the equipment could have been installed on the ground, and then when the trusses were put up in place, it would already be there. Again, you're still installing the anchor, but you're doing it in a safer manner.
Well, the simplest way to stay safe is just build it on the ground. That's not always viable for younger guys that don't believe in paying for a crane to come or owning a crane like I do. But yeah, that's option number one, is build it on the ground. And then you don't have to tie off, and you're not worried about gravity, and then you just pick it up and put it on top of the walls. So that's one way of doing it. Another way of doing it that's more industry standard is that you would, for instance, get your gable truss and sheet it while it's down, and then stand it, brace it, and then roll a couple of trusses. And during that time, you're tying off to the top plates, and you can't really go very far because, if you go out too far and you're up 10 feet or 9 feet, then you're going to hit the deck if you fall. So you have a very limited radius. But once you have a certain amount of trusses rolled, then you can brace them so they're sturdy and could withstand, the impact of a grown man pulling on them. Once they're braced and stood, then you can put your retractable up higher, and then you can roll your trusses. A lot of our jobs, crane, just fly one truss at a time, but that's big trusses. There's a lot of different ways of doing it. We used to always walk the top plates and roll the trusses and bend down and put the blocks in. Now we work off of like scissor lifts, man lifts, whatever, and just, the guy's near plate height, but the plate is actually mid-chest or stomach because he's on a scissor lift, and you can roll the trusses that way. And, and you have a nice platform to have all your blocks. Or you could build scaffolding, but scaffolding has its own inherent pitfalls too, because you got to build it right.
Carpenter's bracket scaffolding. You can use scaffolding as a work platform to roll out, set, and brace the trusses. A carpenter's bracket or top plate bracket scaffolding can be attached to the inside or outside of the exterior walls. Two 2x6 planks or a 12-inch wide fabricated scaffold plank can be used for the platform. Guardrails are required when the platform is more than 10 feet above the floor or ground. When the scaffold brackets are set so that the platform is at least 38 inches below the top plate will become the guardrail.
Leading edge we would define as any place where when a worker's tied off with a fall arrest system and they take a fall, their lifeline, whether that's a rope lifeline, a cable lifeline, their lanyards, could strike that edge, and the anchor point is going to be on one side of the edge and the worker is going to be on the other side of that edge. When we're working in a situation where we have a leading edge, we have to make sure that our arresting device stays with the worker themselves. When we're working with a fall arrest lanyard, that means making sure that the shock pack, the shock absorbing device on that lanyard is always attached to the worker's back D-ring. The reason for that is when we fall over a leading edge, we create a point of friction. We've got that pinch point that's there. If our energy absorber is above that leading edge towards our anchor point, where that point of friction has happened, our energy is not going to transfer up to that anchor point or to where that shock pack potentially could be. It's not going to be controlled and decelerated down to an acceptable level, either the 1,800 pounds or 900 pound average by ANSI, and the worker could be subjected to higher arresting forces or fall forces there. When we have the arresting device with the worker and they take a fall over that edge, it's going to function. It's going to reduce the forces that are put both onto the fallen worker and onto that edge where the lifeline is contacting that edge. It has the ability to reduce how much swinging and bouncing that lifeline has on that edge at the same time. We have leading edge, and we also have leading edges that incorporate sharp edge hazards into them. A good rule of thumb when we're looking at something that could be a sharp edge, whether it's a sharp steel edge or a sharp concrete edge, is anything with a radius on that edge that's less than a number 2 pencil. We want to start taking extra measures on that leading edge to protect against cut hazards on that lifeline from that sharp edge. A lot of this is being addressed through the ANSI standard. ANSI has come up with specific standards for leading edge and sharp edge and come up with specific ways for manufacturers and users to try to reduce the hazards, the cut hazards that go along with those leading edge and sharp edges. The ANSI sharp edge, ANSI defines a sharp edge as anything with 500 thousandths edge, 0.0005 edge on the steel edge, and that's very, very sharp. That's equivalent if you think of the cut end of an I-beam. That's about how sharp that is. And there are some definite hazards there when people are working on leading edges that are sharp and don't have the proper equipment or don't have their systems properly put in place. We have the hazard of cutting the lifeline, definitely whether it's web or cable. We do have cut hazards that are there. There's also, as we said earlier, the clearance hazards that go along with that as well.
Another version of SRL that you're hearing commonly in the market is that of an SRL LE. LE stands for leading edge. Now that's a specifically designed piece of equipment because, again, same thing as with the lanyard connecting devices, we don't always have an anchorage that is here or above. And in that case, using a retractable with foot level tie-off being worst case scenario, now we get to a condition where if this is my walking surface, this is attached to an anchor, And now my D-ring is up in the air 5 foot occasionally based off of the worker's height, and then they fall. Because this works like a seat belt, what happens is we're creating acceleration on a device that's not designed to take that. And worst case scenario is as we fall, what will happen is it will hit this edge and create what is referred to as a shearing effect. This is a condition that has sadly injured numerous workers and sadly made a few of them a fall fatality because the equipment wasn't designed to take that force in that condition, and it sheared, allowing them to continue falling to whatever the lower level was. One of the ways that you will absolutely know that a piece of equipment is or is not designed to be used in that configuration is, of course, to reference the manufacturer's instructions. They are going to be the ones that will dictate what edges it is acceptable to use on. However, ANSI, the ANSI committee that first instituted the leading edge testing requirements, also mandates that the manufacturers clearly identify with symbols a retractable that is or is not rated for leading edge. In general, you will see non-leading edge, and it may be manufacturer specific, where it has a symbol with a red X or some other marking that clearly identifies not acceptable use, whereas if it is, you will see a symbol such as this or other that will show is rated for leading edge. There's a lot more to that you should always investigate and assure again that we are using the right tool for the job. And just because you're working at an edge, whether it's an unprotected side edge or a leading edge, you have to concern yourselves with the fact that if in the event of the fall, the line can make contact with the edge during the progression of the fall, you must consider it a leading edge condition, thus having the right tool for the job versus one that could potentially shear. However, just because you are working where you have an edge and that might be the device of choice, you still have to consider fall calculation and fall clearance, because if you're only 12 feet up in the air and this device requires more than that of total fall clearance, you still haven't protected the worker because, yes, it didn't shear on the edge, but they hit the ground. That's unacceptable. Not because of the law, because your worker hit the ground.
A lot of times when we're talking leading edge or sharp edge, we're connecting our devices at foot level. We could be taking a much greater than a 6-foot free fall. So we have to watch what our total fall clearance is going to be when we're working on leading edges, where we need to anchor our devices, what the charts for those manufacturers on fall clearance say about the amount of distance that's going to be needed when we're anchoring low. Is that device made to anchor right at foot level, or is it only made to anchor down maybe to knee level? What are the maximum arresting forces of that device when used in that situation? If it is 1,350 pounds, where we're used to having a 900-pound device, then we would have to look at how is that going to affect the anchor points that we're connecting to, as well as the structure we're connecting to. If we're using certified anchor points, anything that is designed to a 2-to-1 safety factor, if we designed that for 900 pounds, and maybe we have an 1,800-pound anchor point that we've been using, and we're now using a device that, when used on a leading edge, is going to impart 1,350 pounds of force, we need to know how that's going to affect that anchor point, how that's going to work in that entire system. How far back from the edge we need to connect. The further away from the edge when we're working either on leading edge or sharp edge, the less overall fall clearance we're going to need if somebody falls and goes over that edge. So there's a lot that has to be looked at with leading edge and sharp edge. It's up to the companies to be better educated on what leading edge hazards they have in their facilities or on their job sites, how they're identifying that as either a leading edge or a sharp edge. If we're working in the wind industry and we have a highly radiused fiberglass edge, we probably don't have a cut hazard, but we have still have a leading edge hazard. If I'm an iron worker and I'm walking red iron tied off at foot level and I take a fall and strike an I-beam with my fall arrest equipment, I have a leading edge hazard, but I also have a sharp edge hazard where I need to make sure that I've identified that as a potential area where I could have a cut hazard that's there. Our qualified people and our competent people need to be on the lookout for these hazards and making sure that workers are protecting themselves and using the right equipment that's there.
Horizontal lifelines. One effective fall protection option for protecting workers in leading edge work is a fall restraint system attached to a horizontal lifeline that is anchored directly to the walking working surface. The fall restraint system prevents the worker from reaching an unprotected edge, and the horizontal lifeline gives the worker mobility that would not be possible without a fall restraint system attached to a single anchor point.
So there are differences between holes and openings. A hole is talking about any opening in a horizontal surface. An opening is always going to be in a vertical surface, such as a window opening. So a hole means a gap or open space in a floor, roof, horizontal, walking working surface, or similar surface that is at least 2 inches in its least dimension. So a couple examples of holes that we would see in horizontal walking working surfaces are going to be the skylights that you'll find on roofs. Unless that skylight is designed to meet a certain capacity, we'll consider it a hole.
And a skylight is not designed to keep people from falling through it. So when I was an inspector, I have actually seen skylights with handprints on the dusty part of the plastic where somebody was sitting up there and put their hands on it to stand up. If you're sitting on a skylight, you may have a 25-foot fall to the floor below, and they are not designed to keep you from falling through. So it is important that employers know, number one, if they allow their employees to go on a roof to do maintenance, it's not just the edge of the roof that is the hazard. It's also those multiple skylights. And so there are things that an employer can do, which is you buy guards and you guard those skylights so that a person cannot get to the skylight and fall through.
Another example would be a trapdoor. So you may have a basement or a cellar that has a stairway that goes down to it, and there's a trapdoor that will hinge up. Another example of a hole would be a manhole cover or a utility vault cover. So when that cover is opened or removed, you've introduced a hole into a walking working surface. So an opening in the walking working surface rules means a gap or open space in a wall, partition, vertical walking working surface, or similar surface that is at least 30 inches high and at least 18 inches wide, through which an employee can fall to a lower level. So an opening is going to always be in a vertical surface, such as a window opening if the glass is actually removed. It could be a opening in the wall if there is a debris chute, a trash chute, where there is the potential where an employee could fall into that opening and to a lower level. Generally, the best way to prevent a fall hazard through an opening is going to be with a standard guardrail system.
So basically what you'll see is they'll have the window cut out, right? Your first board has to be 42, give or take 3. And then you go down to 21 and then a toe board. But if you have the window seal and you don't need a toe board or the bottom rail, you just got to protect it.
But that's not always possible, so you may have to use a travel restraint system that prevents an employee from physically being able to get into the wall opening, and in limited situations, a personal fall arrest system.
Holes and Openings Inspection Form. A holes and openings inspection form is a valuable tool for identifying and correcting some of the hazards that are present when working around holes and openings. Module 6. Fall Protection for Construction Conclusion.
One of the top tickets OSHA's writing right now in Oregon is lack of fall protection training for your employees. And then, of course, the question always comes up, how often do I have to do it? Every year? And I'm like, the rule says if you can not show the ability to do it right, or your job changes completely. You know, you go from being an electrician to a framer. What do I think you do? I have companies in this town that are so safety-minded. Every time they start a new job, they buy the boys pizza for lunch, they have me in, and I do the 1-hour class. I got guys with this company that have been through my class 12, 15 times, okay? And every time they come up to me and say, oh, I forgot that. There's nothing wrong. There's nothing wrong with doing it, every year. When you have your big safety meeting, I think more is better. That's me. I've done classes where I've gone in and done the class. 30 days later, they hired a bunch of people. They had me redo the class. People couldn't even do the fall calculations, the ones that just went through my class a month ago. So I think it's a constant evolving thing. Fall protection is two things. It's a series of numbers and it's a series of mistakes. We need to get the numbers right, and we need to take the mistakes out of the picture one by one. And those mistakes are very valuable because they roll, they're like a snowball, they roll big. Once one happens and another one happens, next thing you know, you're hurt really bad and you're hanging there. And so I really think that they need to know what the consequences are of taking a shortcut, what the consequences are of just not paying attention to the rules, or how to put it on, or manufacturer's recommendations. I think you need to know that.
If a person does not know how to put a harness on or inspect their equipment, they shouldn't be out there in a situation like that. I believe it's absolutely critical. And then what training teaches the most is how to inspect the equipment on a daily basis before each use. If you look at the webbing, identify any problems so that piece of equipment can be taken out of service.
Once they know how to use properly, it's not just for them, it's also encouraging others to use it as well. So it goes across the board, like we always talk about, if one of you guys don't want to use it, look what's gonna happen. The other one's gonna probably try to repeat that too. So that's a better, what if somebody gets injured, how are you gonna feel? So really let's not ever set a bad example, let's have a good example. So I wanna make sure that, and let's not look down upon somebody who learning how to use it. Let's make sure that we have a proper training and train them properly and use it. It's gotta be, there's nothing to be embarrassed about it. There's nothing to be, it's part of the, before we use it, let's learn it. Let's learn how it works, because that's the only way it's effective. If you don't know how to use it, I think it's almost pointless, It's actually more confusing to people because they don't know what it is, So yeah, definitely want to make sure proper training is required.
I remember one time up in Longview, Washington, I was back on the job site, an individual fell, and he was the greeter holding his fall protection equipment at the gate as employees came into work. That's training. He was there because he listened, he delivered, and he was there to prompt other employees. I think your best trainers are examples that have knowledge about what they're talking about, because unless they understand the recognition of the hazard, the selection and application of the equipment, the training on that equipment to other employees is well listened by your peers, as opposed to somebody who shows up wearing the tie on the job site. Your peers are important, and they make a difference.
Training certification. In regards to certification of training, the employer must verify that they are compliant by preparing a written certification record. This record needs to have the name or other identity of the employee trained, dates of the training, and the signature of the person who conducted the training or the employer. Once all this is completed, you need to maintain the latest training certification. In some instances, the employee may have received trainings from a previous employer. If the current employer is relying on this, the record needs to indicate that the current employer determined the prior training was adequate rather than the date of the actual training. Retraining. When the employer has reason to believe that an employee who has already been trained doesn't have the knowledge or skills required, they need to retrain that employee. Examples where retraining is required include changes in the workplace or fall protection systems being used that has made the previous training obsolete. It is evident that the employee has not retained the necessary knowledge and skills from the training. Training requirements. Before any employee is exposed to a fall hazard, the employer must provide training for each employee who uses personal fall protection systems, or who is required to be trained as specified by Oregon OSHA.
The most important one would be just taking safety as a cultural change, and it's part of your work. It's not a hassle. Safety all the way down to wearing the right safety glasses, wearing the right boots, no tennis shoes, no short pants, no sleeveless shirts, that kind of thing, and just really embrace the safety culture. Well, not everybody is going to want to do it, but you have to set the tone on your project. If you're going to work here on my job, then you will be safe. You will follow our safety protocols. And if you don't want to do that, we don't want you working with us.
If you just have a mindset of safety, then every potential job, it's one of the things you go through in your mind. If every problem, you stop and think about how can I achieve this, rather than it's a mandatory, or not even mandatory, an obligatory thing to possibly avoid or take a shortcut. But actually, if a person embraces the notion that if I tie off, I'm reducing the ante to play this game.
It's just a matter of, staying on mark and getting more contractors to hold people accountable. And then it starts to become the norm. So I think that's the biggest challenge with residential is you've got all these people popping up to do these houses and stuff, because that's really the residential wood framing is the most dangerous work. I still see it when I go down the road, even on some of these commercial buildings. You've got people doing wood framing, and they get that sense, hey, this is a residential job. I don't need to wear my hard hat. I can wear my tennis shoes. But it's the person that's on the job, that's in charge of that site, that's really going to press the agenda for people to do the right things. If that person doesn't care, it's not going to happen.
Realize that by not having injuries, their comp rates are going to be lower, and that's going to help offset the cost of buying safety gear. So that young potential employer, if he provides his employees with the ability to be safe, he's probably going to lose a lot less employees to people refusing to go to work, going after a close call, realizing that next time they may not be so lucky and go work somewhere else where their health is respected.
Thank you for taking the time to learn about fall protection in construction. We hope it has been beneficial to your understanding of fall hazards and the solutions that are available to keep you safe. If you have any questions about fall protection or other safety and health topics, feel free to contact our consultants. Oregon OSHA consultants are looking forward to providing your company with free and confidential consultations that will not result in citations or penalties. The number to call is 1-800-922-2689. If you have questions about this course, please call 503-947-7443 or email us at ed.web@oregon.gov. If you would like additional educational materials, we have a number of fall protection resources on our website. This includes fact sheets, brochures, upcoming workshops, and our PESO program, which is a collection of bilingual job safety and health trainings. Additionally, for your convenience, we have uploaded the videos from this course to YouTube. Just go to YouTube and search up Oregon OSHA. This will allow you to watch them individually or use them as supplementary materials in your fall protection training. Thank you again for taking fall protection in construction.